Okay, 18.2, defining and evaluating the basic trigonometric functions. Sine of theta is the length of the leg opposite over the length of the hypotenuse. We've already talked about this. Cosine, length of the leg adjacent over the length of the hypotenuse. Tangent of theta is the length of the leg opposite over the length of the leg adjacent. And then we have our special right triangles. I like to actually set these up a little bit different. I like to write this as the 45, 45, 90. I like to put this as a square roots of 2 because it helps me, and maybe it'll help you. This is your 30, 60, 90. Opposite of the 30 is a, opposite of the 60 is a square roots of 3, and opposite of the 90 is 2a. I like to use it to help me when I start doing special right triangles. So I just kind of want to give you how I set it up. Some people like looking at the triangle. We're going to use both of these things in conjunction to find the exact value of the degrees of different triangles. So we're going to be drawing some pictures. We're going to be drawing in those triangles, and we're going to be using the special right triangles with the angle measures to find the exact values. And it's going to require us to remember sine, cosine, and tangent. So up here, we're going to just fill in a few of these just to get you an idea. So we're going to draw a unit circle, and we're going to actually find this column here. So in quadrant 1, we're going to find the 45 degrees, the exact value of the sine, cosine, tangent at 45 degrees. We're also going to find the exact value of the sine, cosine, tangent of 225 degrees. And then down here, we're going to do 120 degrees and 300 degrees. This is the process in which you'll do a lot of your work. So I want to make sure that you kind of understand how to draw these out on your own and how we work from here. So we're going to start by filling in this section. So we're going to draw ourselves a unit circle. So we're drawing a unit circle. I'm going to go 45 degrees. 45 degrees is going to be in quadrant 1. It's going to start along here, and it's going to go about halfway. Now, when you draw this, and I just realized you guys can't see this, so let me move this over. So here, our unit circle's right here. So when you draw this, you actually are going to have this little angle in here, and we're going to draw in a triangle. So we're going to take the radius and we're going to drop it so it's perpendicular to our initial side. Now, when we do that, this angle here is 45, this is now 90, and that forces that up there to be 45 as well. So we do have a 45, 45, 90 degree triangle. Now, it's a unit circle, which means the length of our radius is 1, because it's a unit. Now, you need to also remember that this is a square roots of 2. So that gives us a little equation. That tells me that a square roots of 2 is equal to 1 whole. I need to solve that for a, because I need to know what a is. So I divide both sides by the square root of 2. I get a equals 1 over the square root of 2. Now, that's irrational. We need to make it rational. So we're going to multiply the top and bottom by the square root of 2 over the square root of 2 to rationalize. 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 ends up just being 2. So that gives me that the hypotenuse is 1. This side is the square root of 2 over 2. And this side is the square root of 2 over 2. Now, I'm going to use that to fill in my table over here. Okay, so I am going to fill in the sine of theta of a 45 degree angle. Remember, sine is the leg opposite over the hypotenuse. So if we're looking here, opposite of the 45 is the square root of 2 over 2. So that's the square root of 2 over 2 divided by the 1. Because the hypotenuse is 1. I think I said the square root of 2. Anything divided by 1 is simply what? Itself. So we get the square root of 2 over 2. That is the sine. That is that angle exact value. Okay? Cosine. Same idea. Cosine is the adjacent leg divided by the hypotenuse. That's the square root of 2 over 2 divided by 1 again. So this is just the square root of 2 over 2. Tangent. Tangent's a little different because it takes the leg opposite, which is square root of 2 over 2, and divide it by the adjacent, which is square root of 2 over 2. So kind of let's look at that, what that looks like. That's the square root of 2 over 2 divided by the square root of 2 over 2. Well, we don't really divide fractions. We flip it over and multiply, and then everything cancels out. So we get that the exact value of the angle for 45 degrees for tangent is just 1. There's a lot of different pieces that we're going to be doing, and I know right now they don't all fit together, but I promise you they will in the next coming days. Quadrant 3, we're going to find the exact value of 225 degrees. We're going to find the sine, the exact value of the sine of 225 degrees. So we're going to, again, draw a new unit circle. Okay? We're going to use that unit circle to answer all 3. So even though we're drawing another unit circle, we're using it to answer 3 questions. So here we go. Here is our unit circle. That means the radius is 1. 225 degrees. Well, I know that this over here is 180 because I'm going halfway around. So I know I've got to be down here somewhere. So I need to think 225 minus the 180 leaves me with 45 degrees beyond. So I'm going to do this one in purple so maybe you can see it. Here's my initial side. And it's going to go 45 degrees into this one. So it's all the way over here. That's the angle of 225 degrees. But we don't want to put that arc in there because it's going to interfere with our thing. So it ends here, and we're going to drop the perpendicular. Now the perpendicular, when you drop it in, it always goes to the x-axis. It never goes to the y, just to the x. So that's 90. This is 45, which forces that one to be 45. We're back to the same thing. We have a 45, 45, 90-degree triangle. The ratio is a square roots of 2. My hypotenuse is 1. So that leaves me with my little equation. A square roots of 2 equals 1. Solve that for a by dividing out the square root of 2 both sides. So a equals 1 divided by the square root of 2. And rationalize it. So now a equals the square root of 2 over 2. Isn't that the same thing we found before? You should hopefully start to see patterns as we go through here. That means this is the square root of 2 over 2, square root of 2 over 2. So we write that up here on our circle. So our angle 45, which is actually the angle of 225, for sine, it is the opposite over hypotenuse. So the square root of 2 over 1. But here's the catch. Notice when I go to the left on the x, this is a negative value. And when I go down on the y, it's also negative. So even though our numbers are the same, the sign is different. So it's important to pay attention to which quadrant you're in and how you're moving on the x-axis and the y-axis. So sine is opposite negative square root of 2 over 2 over the hypotenuse. So that would be negative square roots of 2 over 2. Cosine. Cosine of that angle is the adjacent over the hypotenuse. That's still negative square root of 2 over 2. Now, watch the tangent. The tangent, I'm taking negative square roots of 2 and dividing it by negative square roots of 2. We did that before. So, negative square roots of 2 divided by negative square roots of 2 over 2. When we're looking at this and simplifying, remember, we don't really divide fractions. We flip it over and we multiply. But negative times a negative makes it a positive, so we end up with a positive 1. Okay, we're going to go on and we're going to do some angles of rotation with some other ones. Now these both ended up 45, 45, 90. I don't know. What do you think these might end up? 30, 60, 90 maybe? So let's try that. So again, we start with that unit circle. Here we go. 120. They're telling me it's in quadrant 2. So if this is 90, 120 minus 90 is 30. That means I'm going 30 degrees in to this angle. So from here to here, there we go. And we said we're going to drop that perpendicular into the x-axis. All right, so let me ask you, if this side is 30, because 90 plus 30 makes the 120, that means that this side has to be 60 degrees. These two have to add to that 90. So my 60 degree angle is here. My 30 degree angle is up there. 30, 60, 90 has the ratio of a square roots of 3 and 2a. So we know that the radius, because it's a unit circle, the radius is 1. That means 2a equals 1. So a is 1/2. Easy peasy. That means this side is 1/2, and this side is 1/2 square roots of 3, which we commonly write as the square root of 3 over 2. So now we use it. We're going to take the sign. I'm going to write these up. This side here, this is the square root of 3 over 2. And this side up here, excuse me, this is not square root of 3 over 2. This side is 1/2. This one is the square root of 3 over 2. Now, I want you to think about this. If I'm moving left on the x-axis, that's going to be a negative. And if I'm going up on the y, that's still a positive. So, sine uses the opposite over the hypotenuse. So, opposite over hypotenuse means I have the square root of 3 over 2. And if I divide that by 1, I just get the square root of 3 over 2. So the exact value of the sine of 120 degrees is the square root of 3 over 2. Now, we're going to find the cosine. Cosine. We're here at this angle. Cosine is negative 1/2. Negative 1/2 over 1. Well, negative 1/2 divided by 1, I'm going to move this one up. Negative 1/2 divided by 1 is just going to be negative 1/2. Tangent. Tangent is the opposite over the adjacent. So I have square root of 3 over 2 divided by negative 1/2. So the square root of 3 over 2 divided by negative 1/2. Remember, we won't really divide fractions. We multiply by the reciprocal. So the 2's cancel, and I get the negative square root of 3 over 1, which is just negative square roots of 3. So we're going to do the same thing. We're going to try it with 3 this video tonight. Yes, I apologize. It's going to be a little long, but there's a lot of stuff here. So again, unit circle. 300 tells me quadrant 4. That means 270. That means I'm 30 degrees in over here. This to here is 270. 270 plus 30 is 300. Remember, that perpendicular goes into the x-axis, so it's got to go up. If this side is 30, that means this side is 60 because the two have to add to 90. So we're dealing with the 30, 60, 90 degree triangle ratio a square roots of 3 and 2a. Across from my 90 is 1, so that means that 2a equals 1, so a is going to be 1/2. So that side's done, and this is the square root of 3 over 2, because we already decided 1/2 times the square root of 3 can be written square root of 3 over 2. So we want to fill these in up here. So across from the 60 is here, so this side is the square root of 3 over 2. This side is 1. However, since I'm going down on the y, that's going to be a negative square root of 3 over 2. And we're on the positive on the x, so that would be a positive 1/2. So at 300, when I have the sine of theta, sine means opposite. So opposite over the hypotenuse. So opposite is negative square roots of 3 over 2 divided by 1 is just going to be negative square roots of 3. Cosine is adjacent over hypotenuse. So that's 1/2 divided by 1, which is just 1/2. And then we have the tangent, which is the opposite divided by the adjacent. So negative square roots of 3 over 2 divided by 1/2. Negative square roots of 3 over 2 divided by 1/2. Remember, we don't divide fractions, we multiply by the reciprocal. So I still get a negative square roots of 3. So that part is done. We'll practice a couple more tomorrow, but I want to take you into the next one on how to evaluate the trigonomic function using the quadrant and reference angle to determine the sine and absolute value of the function value. So we are going to go over here. We're given it this way. So basically what we're going to do is we're going to put it back as an angle. And we're going to find the actual exact value. We're not going to put it back as an angle. I apologize. We're going to find the exact value. We're going to change it to a degree first so that we can find that reference angle. So we need to figure out what quadrant this is in. Well, it's going to be between 0 and 2 pi. So if you think about it, this is like saying 4 pi plus 4/3 pi gives me 16 pi. Okay, because this would be 12 pi over 3 plus 4/3 gives me 16 pi over 3. So this means I'm going around the circle 4 times, and then I'm going to stop 4/3 of the way through. So when you're thinking of a circle, remember, 2 pi is all the way around, so pi is going to be here. So going a little more beyond that, I'm going to be in that 3rd quadrant. Okay, and it's important to understand which quadrant you're in. So here are some steps. Identify the coterminal angle between 0 and 2 pi. Well, I need to figure out what the angle would be. So here's this. I am going to take my the coterminal angle, 4/3 pi, because remember we determined this was 4 pi plus 4/3 pi. So I'm only going to concern myself with the 4/3 because that's the partial. And I'm going to subtract out the pi. And that leaves me with theta being 2 pi over 3, because this is 1 over 1. So we're putting this down. If you change the 1 over 1, it's 3 over 3. So you get 1 pi over 3. We need to get the coterminal angle so that we can go through and find the degrees. I can change this, the pi over 3, 2 degrees by multiplying it by 180 over pi. So that gives me 180 divided by 3, which is 60 degrees. So now that we have our degrees, we know that it's 60 degrees, so I know I need to use a 30, 60, 90 degree triangle. This is A square roots of 3, and 2a. We know that the unit circle, this is 1. So 2a is 1, which we've practiced this. So a is 1/2. And this is the square root of 3 over 2. So my reference angle is 60. We want the cosine. So the cosine is going to be the opposite of the 60 divided by, it's the adjacent side, divided by the hypotenuse. So this is in quadrant 3, and we're going to draw it, just so you guys get this idea. We're 60 degrees in, right? So opposite of this is the square root of 3 over 2. This is your 1/2, but you're going negative, and this is the 1. So we're in quadrant 3, so they're both negative. So to find the cosine, we simply want adjacent divided by the hypotenuse. So that's just negative 1/2 divided by 1. So the cosine of 16 pi over 3 is equal to negative 1/2. It's very similar to what we were doing, except we have to convert the radians to degrees first, and then find the reference angle. Move the table down just so you guys can see a little better. We're going to practice another one. Same steps. So the first things first is I need to compute this. This is the same thing as 2 pi plus 3/4 pi. So we want to figure out how many times around we're going. So I don't care that I went around once complete time. I care about this 3/4. So I'm going to multiply the 3/4 pi times 180 over pi. Now, the 3/4 pi, I'm going to rewrite that as 3 pi over 4. I don't have to subtract pi off this time. Actually, I take that back. I do because I want to figure out where we are. So 3/4 of the way around, pi puts me in this quadrant. So if I take that, I have to figure out how far in I am. So I have to take pi, subtract the 3/4 pi, which leaves me with 1/4 pi. So that tells me how far in I have to go. Pi divided by 4 times 180 over pi gives me a value of 45 degrees. So what that tells me is when I draw my circle, by subtracting off the pi, it's telling me I'm 45 degrees into this here. Okay? Drop this down to your perpendicular. That means this side is also 45. So I'm dealing with a 45, 45, 90-degree triangle, A square roots of 2. This becomes A being, so this is 1, and that means that A is the square root of 2 over 2 from what we've done before. So the square root of 2 over 2. And the x value is negative. The y value, in this case, is on the positive side. And we want the tangent. The tangent says the opposite over the adjacent. So the tangent of 11 pi over 4, the exact value, is negative square roots of 2 over 2 divided by the square root of 2 over 2, which just ends up being negative 1. I know this was a lot. Please, please, please write it all down.